Consider the function f of x is equal to 1 plus 2x squared all divided by x squared. For what values of x is f increasing? Justify your answer. For what values of x is the graph of f concave upward? Justify your answer. And does the graph of f have any points of inflection? Justify your answer. Let's get started on part A. We're going to begin by finding the derivative of our function and then any critical values. And since we have a quotient here, we're going to have to use the quotient rule in order to find it. So the quotient rule is the bottom times the derivative of the top, so top prime minus the top times the derivative of the bottom, or the bottom prime, all over the bottom squared. Okay, so our bottom is x squared, and the derivative of the top is 4x. And then minus the top, 1 plus 2x squared times the derivative of the bottom, which is 2x, all over the bottom squared. And x squared, quantity squared, is to the 4th power. And if we simplify from here, we're going to have 4x to the 3rd minus 2x minus 4x to the 3rd all over x to the 4th. Notice that our first and last terms, should have included the negative there, cancel each other out. So we have negative 2x over x to the 4th, which can be reduced to negative 2 divided by x to the 3rd. And now if we analyze f prime of x to determine the critical values, well, we have a rational function. There's no place where the numerator is equal to 0, but the denominator is undefined when it is equal to 0. So therefore, our critical value that we have is x equals 0. And if we create our number line that we usually use to analyze our function, it'll look something like this. And if we substitute in a number that is less than 0, say negative 1, into our derivative, we'll get negative 2 over negative 1 to the 3rd, which is negative 1. So that would be negative 2 over negative 1, which is positive. And then if we pick a value that's greater than 0, say 1, we'll substitute that in for x. Negative 2 divided by 1 to the 3rd is going to be negative 2 over 1, which is negative 2. So that'll be negative. Therefore, we know that f is increasing when the first derivative gave us a positive value, so on the interval from negative infinity to 0, because f prime of x is greater than 0 on that interval. Now let's look at part B. For what values of x is the graph of f concave upward? Justify your answer. Well, concavity is found using the second derivative. So let's start there. We're going to find the second derivative and any critical values from it. And in part A, we found that f prime of x, or the first derivative, is equal to negative 2 divided by x to the 3rd. We can rewrite this as negative 2 times x to the negative 3rd power. And from here, we can use that in order to calculate our second derivative. It's going to be negative 2 times negative 3, which will be positive 6, x raised to the negative 4th power. And we can rewrite that as 6 divided by x to the 4th power. This problem could have also been done using the quotient rule again. And by doing so, you would have the bottom x squared times, the bottom x cubed times the derivative of negative 2, which is 0. That's how we get a 0 here, minus the top, negative 2, times the derivative of our bottom, which is 3x squared, all over x to the third raised to the second power, which is x to the sixth. And when we simplify, we will still get 6 divided by x to the fourth. And from here, the critical values, just as the regular derivative, occur when x is 0 because we have an undefined function. So if we make our number line and then pick points above and below our critical value of 0 using, say, -1 and +1, if we put -1 in for x, we'll get -1 to the fourth, which is +1. So we have 6 divided by +1, which is a positive value, +6. And if we substitute 1 in here, we will get 6 divided by 1 to the fourth, or 6 divided by 1, which is also positive. So the function is always concave upward because f double prime of x is greater than 0, or produces a positive value, for all x values within the function's domain, which is from -infinity to 0, because we can't have a value of 0 in the denominator, in union with 0 to infinity. Now let's answer part C. Does the graph of f have any points of inflection? Justify your answer. There are no points of inflection in this function because we actually found, when answering the last question, that it was concave up for all x values within our domain. So therefore, because the concavity never changes, there are no points of inflection.